Our next example says a business has a fixed cost of $200 and 100 items cost $1,000 to produce. Find the cost function, assuming that it is linear. All right, well, functions have two variables, and let's call one of them x, and the other one will be c, or c of x, which of course is going to be the total cost in dollars. Now, the total cost depends on what? Well, it's the number of items produced. The more items you produce, the more it costs you. So that's going to be our x. Now, in business, total cost is equal to the variable cost plus the fixed cost. It says to assume that the cost function is linear. Now remember, in the last section, linear meant y equals mx plus b. Using our new notation, our function notation, a linear cost function is going to be a function of the form c of x equals mx plus b. Now, the fixed cost is going to be that y-intercept, and the variable cost is going to be the mx term. So notice in this problem, it tells us that the fixed cost is $200. So they're telling us what B is. The fixed cost is 200. And they're also telling us that the total cost, which is C of X, is equal to $1,000 when 100 items are produced. What are we calling the number of items produced? We're calling it X. So when X is 100, the total cost is 1,000, and we know the fixed cost is 200. This is going to allow us to figure out what M is. To solve this equation for M, I'm first going to subtract 200 from both sides of the equation. On the right side, on the left side, 1,000 minus 200 is 800. On the right side, the plus 200 and minus 200 cancel. I'm just left with m times 100, which of course in algebra we would typically write as 100m. And now to get the m by itself, we divide both sides by 100, and m is equal to 8. So now knowing that m is 8, we can plug that back into our linear cost function. We already know that b is 200, and so our cost function is going to be 8x plus the fixed cost of 200. That is the answer to the problem.